This video is brought to you by our sponsor PCBWay, a cheap and reliable PCB manufacturer. More about them later in the video. Hello everybody and welcome back to the channel. Today we're going to be looking at PCB design, and we're going to be doing the PCB design in KiCAD 8.0. It's a great open source free software for schematic and PCB design, and it also has many other cool tools that you can use. You can see here, but we're going to be focusing today on the Schematic Editor and the PCB Editor. If you would like to see me show the symbol editor and the food editor, just say it in the comments, and then I'll take a look at if we can do that sort of tutorial. But let's go ahead and see how we design parts in the Schematic Editor and then the PCB Editor. And we're going to be designing today a part for my 737 simulator, and the part is called AFDS, and it is basically a module of the plane that shows you all sorts of warning indicators. So we're going to go and click on new project here, and we're going to save it here. We're going to make a folder and we'll call it video. You just name it what you want the project to be, and we go ahead and save it in here. And then you type in the name of the sort of file. So you want to call it whatever you are going to be building. I'm just going to call it video, since I already have a AFDS panel designed, but I'm just going to redo it for you. So now you have the folder created from the file menu here, new project. You see we have now the PCB and the schematic files. So you click on here, Schematic Editor, and it opens the Schematic Editor. Now you can see with the mouse middle button you can drag this around, you can zoom with the scroll, select with right click, and left click gives you some options here. Then we have some sort of shortcuts here in the keyboards. I'm going to go through them as I use them, but everything is also available on the right hand side on the toolbar. And then we have the sort of grid settings here. We can change to inches, mils or millimeters, and we can do example full window crosshair, so it's like this. I don't like to use it, but you might find it useful. Also the settings here that you can use. For now I'm not gonna go through too deep into those. But now, what you want to do first is, after have you sort of can use the interface, is of course add a new component. And add a new component by clicking here on the right hand side, add symbol. But you can also, and I highly recommend you learn the shortcuts, click A, and that automatically opens the symbol libraries for you. It just loads in them. And when you are in here, you can see a lot of components, or these are actually libraries, and there's a lot of components inside these. And you can see the schematics if you click on them. Now, whatever you're creating, you want to find an appropriate symbol for the components that you are going to be using on the PCB. For our PCB, we will have a multiplexer and a LED controller, as well as 3 tactile switches and numerous LEDs and connectors. So we can start by, for example, adding some tactile switches, and you can here start to type what you want. And here you can see, for example, this sort of looking tactile switch. I quite like this for my tactile switch. So you just double click it, and it comes here, and you can place it wherever you want. Now I'm gonna actually do is rotate it and place it like this. And then what I'm gonna do is, you can either click again, which brings the same menu, and you can click OK or double click and bring again, rotate it, or you can click while it's selected, so Ctrl C and Ctrl V, and copy it like so. Well, now you have these in here. You can go ahead and rename these to what your component actually is, because it doesn't really matter what the value is. You want to have them named so that you know what they are. So we're going to name the tactile switch. And S1 is the indicator that you don't need to change. And what I'm actually going to do is delete these, and I'm going to copy this so we get the name to all of them. It automatically changes the reference number, so you don't get the same reference number for the components. And tactile switches, the ones I use have two poles, but it has 4 legs. And what that means is we only need to use 2, or we can sort of connect the 2 together. And that happens by just simply clicking the leg, and it automatically puts in the wire tool. Alternatively, you can click W on your keyboard, and it enables the wire mode, or you can click on the sidebar here. Now I'm going to connect all of these legs, and then we're going to run a little strand up there, and you need to double click so it ends the thing. Another thing I'm going to do is just going to drag this a little up, so we have the connectors a little bit higher up than the legs there. Just my own preference, it really does not matter, but I do that. Then we connect the bottom legs, like so, and we can also do that, run these down here, and if you actually accidentally drew it too short, just click again and do that, or you can select it and drag it like so. So now we can see that we have the wires in here, and always make sure when you are wiring buttons or anything really that you have the correct legs connected if you want to connect the legs, since you can see on the symbol here that this is the button and these are the 2 sort of poles, and if you press the button it connects the poles. So you would not want to connect number 3 to ground and 3 to your pin, because it would just short it completely at all times. You want to make sure that you are wiring your wires at the correct places. Now that we have these, you can click again A or go to new components, and we can search for the ground, which we can find under power, or you could click from the side menu the add power, or click P, which automatically brings you to a filtered menu with all the different powers. But it doesn't really matter which way you do it. You find your ground, and I like to use the GNDD. And now the upper poles is my ground, and the bottom ones will be my pins. Now I'm gonna leave the pins like this for now, since I don't have the receiving ends yet. But we can put this on the side so we have some more space. And let's go and add some more components. Let's add some LEDs. So again, click A, search for LED, and here we have the typical LED with the 2 pins. I don't want anything like this, because we only have the single LED for our case, but of course you will select the ones that you actually need. And again, we go ahead and place it in. For optimizing my pins and my wiring in the PCB layout, I want to have 2 LEDs in series, so we don't need to use so many wires to connect to the controller. And then I will have 2 parallel to this, or not actually parallel, but these are going to be different color, but they will be like laid out parallel, like so. Then we can copy this here, and I'll have 3 of these modules. And you'll just click Ctrl+C, Ctrl+V as copying anything. And I try to just usually align things to the grid. You can sort of see the grid has this sort of stronger points here, so I'll just try to align things to that, just to make it easier for myself to sort of have everything laid out nicely. It, again, really doesn't matter, just something I do. Before continuing, we would like to tell you a little more about our sponsor, PCBWay.
PCBWay is a part manufacturer who offers PCB manufacturing and assembly, CNC machining and 3D printing services.
Their low prices and endless customization enables everyone to use their services in a moment's notice.
We've already ordered some parts for this project and it was very convenient and easy process.
Go check them out from the first link in the description.
Thank you PCBWay for sponsoring this segment. And back to the video.
So now we have my LEDs here, and I usually like to add all the similar components at once, so I don't need to add 2 LEDs, then I'm gonna wire them up, and then I'm gonna add 2 more and wire them up. I'll just add all of them together at once, and then I'll wire them up. So now, as I said, we'll wire them up. Again, run the wire, like so. You can click W, get the wire. I'm gonna run the wire like so, and then we'll run it down here, connect all of these, like so. And the way the LED controller that we will use works is we will have a 12 volt coming in, and then the cathode will be going into the LED controller. So these are the controller that we use will be a cathode controller, I believe the name is, and you will power them with an external power supply, and the controller will just increase or adjust the resistance to power the LEDs. So what we do is we'll look for 12 volt. Again, we have a lot of different options here. We have minus, plus 12 volts, we have 12P, 12C. I'll select the one that suits my needs best, 12 plus 12V, and we're gonna put it there, and oops, sorry, don't do that. Click W and we can wire it up here. And now we have the power in, and you can see that all the LEDs are wired up. These dots tell me that there is a junction. So now that we have the 12 volt in, again, these rest of these, we can draw a little bit of line here, will be going to the controller, but I'm not gonna, again, write anything down yet or connect them to anywhere since I don't have the controller here yet. You can see I accidentally draw this here, so I'll just drag it down, for example. So now that we have the tactile switches and LEDs, I think it's time to bring in the controllers. The way, again, is exactly like always. Click A, find the Schematic library, and this is a custom component that I did not have in KiCAD natively, so I had to create it by myself. So I created a custom library, and I have my controllers here. Here we have the multiplexer, and here we have the LED controller, and I'm just gonna bring in the multiplexer first, and I'm gonna place it here. And now we have it over here. We need to wire all of these pins in. Now this is where your schematics or that data sheet will come in handy, or knowledge of the components. You need to know how this needs to be wired. But also the schematics usually do say, or if you create it themselves, you need to name the pins correctly, so it makes things a lot easier. You can see at least we have the ground enable pin VCC here, and those are going to be the simplest connections that we have. Ground enable is going to be ground, and VCC is going to be 5 volts in, or you can name it just VCC. What I like to do is again draw a little line out there, and then I'll do is copy that line over to all of these pins, like so. And then when we have one side complete, then you just copy them all to the other side. So now we have sort of a extension legs, and you will see why we need these in a second. So as I said, So you should always just start with the simple ones that you know what they are gonna be. So the ground and enable will be the ground. So what I'm gonna do is to save some time. If you have already placed a component down or a indicator down, you don't need to add it again from the menu here, because you can just select it and Ctrl+C, Ctrl+V, copy it, and this will save you a lot of time. So we're gonna add the ground to here where we want them, and then what we'll do is add a VCC to the end here. So now we have the simple ones, the clear ones here. We can start to connect some actual components into this multiplexer, for example here. The way multiplexers work is we have these Y0 to Y15, so 16 pins total. We have these where you connect your components, and then we have address lines from S0 to S3, so 4 address lines, and a signal which is designated by the Z. And these 5 sort of a control pins will drive the controller and select which component is being read at a time. So obviously we want to connect our components to the Y pins, which are the input pins for the multiplexer components. So usually you just want to start from the 0, or the lowest number that you have on your controller, this time it being Y0, and what you do is you need to add and label, because what you could technically do is draw a line here all the way to here, and now you would have a connection. But we rarely do that, since it would create a very confusing layout with wires going everywhere, and it will be very hard to tell what is connected to where. So the way you usually in schematics do connections like this is you add and label. A label, naturally, you just click L to label things, and it brings up this label properties menu, and here you can type the name of your label. And these you want to keep them short but concise, so that you know exactly what this component is, what it's referring to. Now for my tactile switches, they have specific names. They're going to be the autopilot tactile switch, auto throttle tactile switch, and the FMC tactile switch. And the way I'm gonna write these is gonna be AP and TCSV. So the TCSV will be tactile switch for short. Now it doesn't really matter what you name, and you might want to name them your way. This is just the way I find it easy to name them, but you obviously want to name them the way that you find it the best. So this is going to be the auto throttle, and then finally the FMC tactile switch. So now we have these to Y0, Y1 and Y2. Again, remember what I said, you don't really need to always create new components or new labels. You can just copy them, and you don't need to write things again. Then you can just move them here and set them like this. And one thing I like to personally do is just click R and rotate them along the wires so that they look clean and neat. And one thing you can see here is we have a rectangle box here. It means it's not connected. So what you want to do is drag it in here, and the rectangle goes away. You know that the connection is made. Another way you can always double check, but you don't really need to do it, to check if things are connected, is you can go on the sidebar here, and you can check for highlight nets, and then it brings this tool where you can click any wire, and it highlights to everything that specific wire is connected. So for example, our tactile switch is connected from here and here. Or we can check out the ground, and the ground is connected there and in these two places. So that's one way to check for connections if you're unsure that your nets are all connected. Alright, so now that we have got these components on the multiplexer connected, and we have power coming in, we want to start connecting the rest of these. Now for Y3 to Y15, you don't really need to connect them to anything, or you could make some sort of two-hole mounts for any sort of pin arrays that you would want to do, maybe if you wanted to add some future proofing, so that if in the future you want to use the rest of the pins that you didn't use, you will have an easy output to mount new components to. And I'll show you what I mean by that just in a second. But the next thing after the important components are in here is to just get the mandatory signal and the address lines connected as well. Now, since I'm gonna connecting this to an Arduino, I need these to be connected into a connector that will be coming off the PCB, and then we'll have the wires route to my Arduino. You could technically also model or design the Arduino Atmega chip directly into your PCB and have the connections made directly to the chip, but that would make it so much more complicated and expensive than it needs to be, that I will just be using a connector to connect to an ready-made Arduino. But in its most simplest form, what you want to do is for the addresses, add a new label and call it what you want to call. I'm going to call it mux as 0, as in multiplexer as 0, and mux as 1, and of course here mux as 2, and mux as 3, and again click R to rotate them to the way you want them to be. So now we have these sort of labels called here, which will create a new net, and these can be routed to the connector later on, or now if you want to. I'm gonna hold on the connector since there will be much more to add to the connector, so I'm just creating these ahead of time so that I can wrap up the controller and then move to the next part. So we have the signal here, and exactly the same again. I like to call this mux signal, mux sig, and now you can see that we have the multiplexer address and multiplexer signals made exactly the same way that we created these button labels. Now one thing that is unique to, well, not exactly unique, but one thing that you want to do for the multiplexer, and you would know this from looking at the datasheet, is adding a I believe it's a pull-up resistor to the signal wire, and that is so to reduce noise on the signal wire. And the datasheet recalls for a 2 kilo ohm or between 1 and 5 kilo ohm resistor, and we'll use a 2 kilo ohm resistor just because that's sort of the middle ground. Again, click A, search for a resistor, and we have the R resistor. There are many options you could have. There is the US version, the EU version. I'm in the EU, so we can use the EU logo symbol for this. Add the resistor, add the cable, and connect it here. The dot signifies a connection. Then we'll add a wire this way, double click, and we're gonna add, and this needs to be connected to our VCC, so we'll bring our VCC to there. And now we have a pull-up resistor connected to the signal. Now one thing you might see here is it doesn't have a value. So what you do is double click it and you can edit the value down on the edit value field, and you want to type the value that you want. So 2 kilo ohm resistor, 2 kr is the standard way that you mark resistors. Well, the 2 kilo ohm resistor at least. Later on, we will be assigning the footprints and selecting the specific models for all of our components. So you don't need to worry right now that which specific model this is. This is just the symbol and just the value for your schematic, and we'll look at the footprints and specific components later on after all of the components are laid out. Another thing that you usually want to do with ICs is add a capacitor to the VCC, between VCC and ground, again to reduce noise on the power signal or power input power. And very simply, this is done by adding the VCC, adding the ground like so, and putting a capacitor in between. Click A, search for a capacitor. You can find C. This is fine. Click this, put it there, and connect the wires. And I usually want to group them. So you want to have this capacitor as close as the IC as you can. At value about 100 nano C will be fine for our application. Again, you want to see what is good for your application, but for our multiplexer 100 NC will be fine. One thing that you don't really need to do, but I like to do, is since this is going to be sort of a single sort of area on the PCB, these need to be grouped together. What I like to do is, just for the cosmetic reasons, on the side click add rectangle, and we'll draw a little box around the area that I want to sort of enclose in, to signify that this is gonna be one area of the PCB and these things need to be close together. This is something that I like to do, nothing that you actually need to do. So we have our multiplexer basically all good. If you wanted to, as I said, you could add the labels for all the rest of these pins and just add them to a random pin header on your PCB for easy access if you ever wanted to. It's not necessary. I will do that, but that's gonna take time to do, so I'm not gonna show it in the video. Now that we have sort of this IC laid out here, I could show you again how to create the IC for the LEDs, but that's gonna be actually pretty much exactly the same with just a little bit different pin names and different resistor values, but you get the point. So I'm just gonna skip that part too, and we'll just I'll just do it off camera. But there is a few more things that I want to show you before we move onto the PCB. So I'm gonna go ahead and finish the part that I need to do, and I'm gonna come back and show you what I've done. Alright, welcome back. Now I have added the LED controller as well, wired up everything. I've added the sort of redundant output pins here, and we have got connectors, and we have got some through hole mounting points for all sort of things that I wanted to add, and these all depend on your specific design, and these would be added exactly the same way as any component. The ones I use here are called test points here, and you could select really any test point symbol, it doesn't really matter. What I use is just a simple test point. and I have renamed them THD since for my PCB they're gonna be through-hole points for sort of pin arrays to go into. You can see here we have a header, 2x8 header, and here we have VCC, ground, 12 volt, the latch, data in, clock, and all the multiplexer signals coming in. They are named exactly the same name that is connected here in order to have the net connect between them, as I explained to the switches. And then, since I'm using a 2x8 connector, since that's what we have, I was left with a few empty pins, and I decided to fill those with ground, so we can have some extra grounds coming in. You can see we have total 6 ground pins in between all of these. One ground is connected like so we didn't need to add the symbol in the signal separately. And you might notice that I have also placed the grounds so that they are surrounding our voltage pins. That's in hopes of reducing noise, but that might not matter at all for your case or even for my case, since this is just a simple simulator part, flight simulator part, simple IC, simple controllers. So once you have all of the components, all of the connections done, everything's looking good, you might be thinking, okay, then we're done. But there's a couple things that I want you to realize and think before you start moving the PCB is how will the PCB be mounted onto the part that, or how will the PCB be mounted to anything? Or will it just be floating somewhere, right? So for mounting the PCB you would usually use screws. And adding screws to the schematic might seem stupid, but that is how it is done in the Schematic Editor in KiCAD. So what you want to do is click A and search for mounting holes. Now there's mounting holes with pads, so this is basically to ground your mounting holes if you wanted to ground the screws or the whole chassis to the PCB ground. I'm not going to do grounding the holes, so I just select the mounting hole without any pads. And in fact I have already got them down here, and sorry, I have named them like so, and I will have total 4 mounting holes. And then another thing is, practically speaking, everything is now in place and this is ready for the PCB layout. But one thing that I need you to do is also add some power flags. Now these were something that when I was designing this design I didn't put this in, and then when I went to do the ERC, electrical rules checker, which checks the PCB schematic sort of functionality, it gave me an error that the ground, 12 volts and VCCs were not properly flagged as power inputs. And it doesn't really affect anything except it gives you the error, and if you wanted to do some simulations it might affect that. If you were to now export this PCB or export your PCB layout and buy a PCB from a manufacturer, these power flags would not do anything for you, but they are really easy to add. You need to add them to every power input / ground that you have. It's very easy to add them. You just click P for the power and you search for power flag and put it in, connect it to the ground, 12 volt and VCC. And the ERC will no longer complain about anything. Speaking of the ERC, you always want to run this, check for any errors that there might be. I don't have any errors, but you can see if I remove the power flag here, delete it, run the ERC, now it gives me an error on input power pin not driven by any output power pins. That was the power flag issue, so we add the power flag, run the ERC again, and we are all clear. Another thing that it might complain is if you are shorting power. So if you do that, it's not gonna like that I have a short between ground and 12 volt. So these sort of error messages are to be expected, and the ERC helps you fix those. It's a very nice tool to have to make sure that your design is all properly made and you don't have any mistakes, because mistakes are very easy, so you need to be just very careful. These sort of mistakes would be found when you're doing the PCB layout, but always just when you're done, run the ERC and carefully check all of your connections here, especially so that you don't have any shorts, or that all of your pins are named appropriately, because these pin names is how you will start making the PCB layout, which, speaking of, is the next step. And those next steps will be shown in the next video in part 2, where we'll go through assigning the footprints and actually designing the PCB layout on the board. And that is actually not very difficult, and the video is gonna show you everything that you need to know. So we'll see you there. Thank you so much for watching, and thank you PCBWay for sponsoring this video. Without you, it is not be possible. Thank you everyone, and goodbye.